That means it's filming?
Yeah, it's right here. So you gotta go to there.
It was filming while I was fixing.
Are you ready?
Yeah, sure.
No, the others. Okay. We already talked a bit about incident angle modifiers, and so I just want to make sure everybody knows what an incident angle modifier is and what is possible with a solar simulator and what's not possible with a solar simulator. So, what we compare all of our measurement results with is at the moment from that the light comes from a perpendicular to the collector. So that would be the collector plane, and this would be the irradiance. So the incident angle modifier determines a factor of the efficiency decrease if the light comes from a different angle. Okay, for a third.
The angle is measured from the normal?
Measured from the yeah, it's here. So that's normal here, and we rated
Normal angle here.
Yeah, that's incident angle is defined that way.
yeah. So yeah. So I will come to that. So it's what you basically do normally for incident angle modifier testing. If you go for, I would explain that from a steady state testing point of view. What you do, you have a collector on a tracking system, for example, and then you have the sun, which is coming from here, and then you put the collector in a different angle from the normal from the sun. So what you basically do for that is doing that only at 50 degree, and then by a method called, there are two methods actually. There's one method which is called Ambrosetti formula, and the other one is called V0 method. And you measure only the 50 degree point, and then you get this curve out of that. So, maybe to say, some simulation tools, whenever you use them, they want, if you want to simulate your system for the entire year, some simulation tools take the B0 value, some simulation tools use the Ambrosetti formula. So, just for you to know, there are some tools which use the one method, some tools use the other method. If you do simulations with transit or whatever, make sure that you take the right value. Don't take the B0 value for the Ambrosetti formula or the B0. They will not fit to each other. I have some, maybe I have another presentation I can show you with some more things about that. So this is our typical incident angle modifier of a flat plate collector looks like. This here means angle theta in degrees. That's great. So if you look at a vacuum tube collector, a vacuum tube collector has two different incident angle modifiers. One is a transversal.
Like this one.
One is a transversal. The other one is a longitudinal. So depending on how you can, depending on how you look on the collector. So you see, one is rising and one looks pretty much the same as a flat plate collector. That depends on the geometrical shapes you look on the collector. If you look from point one, your geometrical shape is like this, right? A lot of tubes next to each other. And if you look on from point two, you have a different shape, which is flat, which looks identical as a flat plate collector. So this one is point of view 1, this is point of view 2. This is a flat plate collector. So point of view 1 and point of view 2 and flat plate collector identical. Point of view 1 looks a bit different. I will explain you why. So this is your tube, right? This is our pyranometer, so our irradiance sensor. So if the sun comes perpendicular to the tube, we have this is our acceptance, right? All this way, the vacuum tube accepts the solar energy. This is a pyranometer, the same. So this is the area where it's active, right? So, okay, now we go to a different area. So maybe 45 degree. It looks like here. This area still the same, right? Pyranometer, because of the cosinus factor, it's a smaller area, so we measure less irradiance. Coming back to that presentation, we still have the same energy which is coming to the tube, but we measure less energy coming to the vacuum tube. This is why theoretically the energy from the IAM is getting higher, right? In theory, it's also if the sun comes from 90 degree, which is or close to 90 degree, the pyranometer sees no more sun, right? But we still have energy on the tube, so the efficiency would go to infinity. So, but we get always to a certain point, which is very high, and then the energy is dropping, or the IAM is dropping again. So this is only true for one tube, right? So, but a collector consists of several tubes. So, to a certain angle, the energy always hits the entire area of one of these vacuum tubes. When the sun comes from a certain angle, the tubes start shading each other, right? And this is why it's decreasing. So coming back from the idea from I was coming from, talking about the incident angle modifier, if you have this is somehow the simulator looks like. If this is coming from a certain angle, so if you talk about vacuum tube testing, normally they are a bit overrated indoors, because this is somehow to an angle of around about 30 degree, or yeah, most just a certain small portion, right? So when we remember back on that, a certain portion of the energy comes from an angle which is still 30 degree. So this is why indoors you overrate vacuum tubes a bit. And for flat plate collectors, this has, you see till here, the standard says it's allowed that 80% of the irradiation has to be in an angle which is smaller than 30 degree roundabout. You see, for vacuum tubes, it already rises at about 20 degrees. So if you have irradiation coming from a bigger angle, then you overrate your vacuum tube collector a bit. So this is why I said sometimes for collector testing, it can make sense to get a bit worse homogeneity from the testing point of view if you put the lamps closer together, because then you have more direct irradiation from a smaller angle on the collector. Got that point? It's a bit complicated, but this is why sometimes it's better to put the lamps closer together. You have more light directly on the.
Okay.
Can somebody nod, and then I will go to the next presentation.
You try to minimize the angle of incidence, right?
Yeah, if you have a very good homogeneity, you will have more light from a more diffuse light in your solar simulator to get really good homogeneity. But it can make sense for certain technologies like vacuum tubes to put that together. If you go for example, concentrating technologies, whatever you use, a concentrating mirror, CPC, or higher concentration ratios than 1 to 3 maybe, this makes no sense to measure that in a solar simulator.
So what matters for this case is the collimation than the uniformity.
Yes, I would say that.
But now nobody's in that room.
You can make your own decision with that, but sometimes, like for vacuum tubes, I would say
It's not to 130 there.
not all the irradiance is coming from an angle which is bigger than 20 degrees, but a certain portion is coming, and to determine that portion is very hard. Then you can make some calculations on that, but all the time you change the configurations of the lamps, it changes. So this is why it's perfect for product development and for a lot of comparison tests. But always, if you do your test, put your collector on the same position, put your lamps on the same position. Especially for vacuum tubes, this is essential. If you test, for example, if you want to test vacuum tubes, that vacuum tubes with different diameters, inner and outer diameters. Sometimes I had the case in the past from a company or a company I know or institute I know. They were asked. It was winter. The customer wanted to compare different sizes of vacuum tubes to each other. Which vacuum tube, the bigger one or the smaller one, is better? They asked to do that in a solar simulator. That's not possible. They have different geometrical shapes. You cannot compare one geometrical shape with the other one. This is very, very difficult to say then from which angle the irradiation came. So
just a quick question. For our system, what's the percentage of the radiation in the 0 to 30 degree?
from 0 to 30 degree, I think it's 100% from 0 to 30 degree. If you go more, I think the angle is 30 degree or something like that.
Yeah, I know from the lamps.
Yes.
I'm talking about the incidence angle on the collector.
Yeah, but you cannot have any angle which is bigger than the
30 degrees.
than the 30 degrees.
Yeah. What about due to reflections, or that's not very much?
No.
Not very
Sure,
much.
you will have some from the room, but your room is dark,
Yes.
so you will not have many reflections of the room.
So it's 0 to 30 degrees,
Some
almost 100%.
Almost 100%, yes.
Okay, so for the flat plate collectors, we don't have any significant.
No, not any significant change. Also, vacuum tubes is fine, and you want to change the coating or whatever, different header, different. You want to compare.
You understand why it's going up? It's because the projected area is smaller. So basically, I mean, this accounts for the decrease in projected
Yes.
area that peak. He doesn't use the term projected area, but that's not the term.
Yes,
Projected area.
the
you know.
projected area is
Yeah,
smaller.
so the projected area is smaller, so that rise accommodates for the reduction in projected area. And then it goes down because of the self-shading.
Yeah.
I keep talking, I'm teaching in between the measure course and daylight, so I keep talking
Yeah, it's
it's
great.
about projected area.
It's for me. It's great to know. I will add that.
But not everybody has taken, there is a solar course, so not everybody has taken that one.
Okay.
So,
For me, it's great. I will add that for the next time. I will give that presentation. I will add the projected area.
it's probably easier to follow, but
Yeah.
the term projected area,
Yeah.
because that's the term most people use. Okay. Apparently the food is downstairs, and because we changed the room on the 7th floor, so we'll have to go. You know, because we had more keyboard, there was a last minute change of the room, but the caterers apparently were not informed. They took the food downstairs, so if you finish quickly, then we can.
That's fine. I'm finished with that one.
Okay.
I'm finished with that presentation.
So, can you just put the back slide? Okay, now everybody understands what this thing is. I mean, it's the lamps. So they have a 30 degree, the cone of the emitted light has a 30 degree angle. And So everything, and the reason for that is to basically not need the correction for the
Angle of incidence.
basically, in an angle of 0 to 30 degrees, the transmittance of glass doesn't change very much.
Yes.
So
Ah.
that's,
If you, I don't have internet. For example, if you go to a manufacturer of also anti-reflective glass, you will see that they have also the curve of the incident angle modifier, and they say normally basically at 35 degrees the reflection is starting to grow.
yes. So that's really, yeah.
Okay, lunch
And-
is ready.
Okay, we go downstairs, all of us. Okay. And it would be a bit